We're going to talk about the program structure, and we're going to do it with a simple C program example. So there is a methodology called the 5-step problem solving methodology that is really useful when you are programming or for really to solve any analytical problem. Let's have an example. Let's say we want to compute the straight line distance between 2 points in a plane, a very common mathematical problem. So the first steps will be first to state the problem clearly, then describe the input and output, then work a hand example, develop the solution, which in this case is going to be an algorithm or a computer program, and then test this solution. So the first step will be again stating the problem clearly. So we know what we need to do, which is computing the straight line distance between 2 points. So we figured out what are these 2 points and how to draw them in a plane, and that with the formula to find the distance is the one given on the screen. So the second step is to describe the input and the output. Well, in this case, the output, which is the outcome of our program, is going to be the distance. So the output will be the solution, and the input will be the elements we need in order to solve the problem and give this output, which actually are the 4 coordinates for the 2 points, or x1, y1, and x2, y2. Now the next step, the third step, will be work a hand example. So let's say we have these 2 set of points, 1, 1, and the next point is 3, 4. We plug that in our formula for distance, and we obtain the distance, which is 3.6. So very simple. Now that we know how to solve the problem and by hand, then we can develop a solution using a computer algorithm or a program, which will be step 4. And when that is done, the final step is to test our solution. Now step 4 and 5 is where our programming languages will come to play. In this case, where C is going to come to play, and it's going to help us to find a solution. Now, this is how a simple C program looks like. And the first section that is in green are the comments. The next one, which is in orange, is the preprocessor directives. And the final section there, between those brackets, is the block of code. So the first section, the comments that are in green, are really there to help people reading your program and are completely ignored by the compiler. And a computer code is read by the compiler or by the computer like you would read a book, from top to bottom, left to right. So when the computer meets this piece of code, it will start with the first line on the top and the first character on the left. So it will identify that there is a / and then an asterisk, and it will know that whatever comes after that, it has to be ignored because it's a comment. Now the computer knows the comment is finished when it encounters the combination of an asterisk and another /. Now there is another way to define a comment, and that's using double / or 2 / after one after the other, as you can see in the next block in orange. So the difference is that the first way is to define a multi-line comment, as you can see, and the second way is to define just a one-line comment. So whatever comes from those double / to the end of the line will be ignored by the compiler. So it's very important that you remember this and you put as many comments as possible as you require to fully understand your program. And that's because if somebody else sees your program and needs to make modifications, without comments it will be really hard. It will be a task in itself to figure out what you did. But with comments, it will help the programmer to figure out what you did and make the changes. Not only for others, but also for yourself. And I find myself many times having to rely on my comments years after I program something to remember what I did. So it's a very important part of programming. Now the next section is the predecessor directives, and they are in orange in this example. So these are really instructions that are provided to the compiler to be performed before the program is compiled. They begin with the £, and that example is what you see there on the screen. So, for example, the #include directive instructs the compiler to include statements from the file stdio.h, that is an external file. So what it does, it's bringing instructions or code from a different file and annexing it or including it to your code. This really helps with modularity, and so you can use also external libraries and code that has been done by somebody else that can be integrated into your own code for different use. Now the next section is the block of code, and that's really where everything else is included, and it's defined by a bracket, and every C program contains exactly one function named main. So when you see the main function or the main letters with the parentheses, you know that's the main function of a C program, and you know that it's where the C program is going to start, or where the block of code, or where the actual code is going to start. The rest is really preparation, what is before the main function. And the C program solutions always begin execution in the main function.